Welcome to our tutorial about OOP, or OOP, which stands for Object-Oriented Programming. Any discussion of OOP requires an explanation of another acronym, IDE, which stands for Interactive Development Environment. We've been using such an environment in every lesson in this course, whether we've been aware of it or not. Many different IDEs exist, depending upon the language and the manufacturer that provides that. In a nutshell, IDE, or Interactive Development Environments, exist to make our lives as programmers easier. In our case, we want to create a Visual Basic application. We can use the Visual Basic 2005 Express IDE or one of the versions of Visual Studio 2008's IDE. These environments both provide a number of tools for creating, debugging, and releasing applications, and IDEs make these processes faster and more efficient. Compare it to the old-fashioned way of writing programs where you'd use Notepad and then compile it by hand afterward. That is definitely the slow way. Modern IDEs allow for dramatically increased productivity. Let's take a moment to talk about object-oriented programming, which we've been working with all along. For example, our form interface has a standard Windows look and feel, even though we didn't write a single line of code for this. Now let's go to our code window. Here we see some statements: public class, form 1. A form is a class within Visual Basic. Let's talk about another example of class, for example, buttons. Now we've got two buttons. The buttons in my toolbox are a class. However, the two buttons that I see in my form are instances of this class. Let me provide another analogy to help make this a little clearer. For example, you would send your drawings to an automobile manufacturer who can create more than one car from the same set of drawings, each auto having different parameters: one green, one red, one with these tires, one with those tires, some with various different features inside the car, etc. In object-oriented programming, the drawing is like our class. However, the cars that we create using the drawings are called objects. Those are instances of the class, just as the cars are instances of the drawings. Both of these buttons were created from the same blueprint, but we can change the individual parameters of these buttons independently. For example, the back color, we can change the size by dragging the handles, the font, and so on. But the object we're dealing with remains a button. In other words, it still looks and behaves like a button. The button in our toolbox is a class or a set of blueprints. When we drag it into our form, we create an object with those blueprints. To be even more specific, the IDE, or Interactive Development Environment I'm using, Microsoft Visual Studio in my case, created an object button in response to my action of grabbing, dragging, and dropping the button from the toolbox onto my form. Now, when I double-click on this object, the IDE writes a block of code for this object. Even if this seems a little bit confusing now, stick with me. It'll make more sense in our subsequent tutorials where we'll be creating our own custom classes. And this concludes our introduction to Object-Oriented Programming, or OOP, OOP.